All right, so here I'm gonna talk to you about my presentation, modeling periodic functions for my project in pre-cal. So I'm gonna give you a quick introduction into my project. So my project is we're gonna be using we're gonna be consisting of clock. So I want to see how long the time period of 12 hours will be, and what exactly is the height and of where my clock's gonna be. And not only that, before we get into right into that, I would want to give you a quick introduction on how exactly I got the idea of the clock. So in my class, during October, well, when we were doing this project, we were supposed to find a Ferris wheel, and during when we were supposed to find a Ferris wheel, we were told to see where exactly will the Ferris wheel land at what specific time. So this gave me an idea for using a clock. So to see as a Ferris wheel was a perfect example of a periodic function. And not only that, I thought of something very like a periodic, like something that rotates again and again. So that's the idea that I got from a clock. So here we have my function graph, which you can see that you have the height in centimeters and you have the time in hours. So that's the variables we're going to be using in my graph. So you can see that it's very periodic, and there's no questions asked. As you can see, you could barely see is like these little dots, which means signify my periodic function, in which these are basically the hours. What height is in the hours. So it'll be 1 hour. It'll be at like 0.5 centimeters. And the more it goes up, the height, so at 12 o'clock is the highest point. So it'll be roughly around like 35 centimeters. So that's a quick graph. So right here we have our scatter plot. Such a much better visual of where my hours and my time will be. So right here you can see that like how I was explaining, like the 12 hour mark is the highest point, and the lowest point will be 6 o'clock, since that's the lowest point at which a clock lands on. So yeah, as you can see, it's much a better example of my points. So we have my data table here. So my data table is right here explaining where the points are consistent. So I started off from 6 o'clock to 7 to 8, 9, and consider to all the way to a cycle of one full cycle. So to see if my graph was periodic or not. So as you can see, it's very periodic. There's like numbers repeat, since it repeats itself every single time. So that's one thing that I did, and you can see like the period, like stuff like that. And now we're gonna be talking about my properties in periodic phenomenon. So right here we can see my maximum value, which is 35 centimeters. My minimum value is 0 centimeters. My amplitude is 17.5 centimeters. All this will be in centimeters right here. This guy right here. So my period will be 12 centimeters. My B, in this case, will be my 0.52 centimeters. And my horizontal shift will be 0. My horizontal shift will be 0 because we're not rotating towards up or left. Like we're not gonna be going to a horizontal shift. So that's the reason on that. And then H, is 6. So that's gonna be my thing in centimeters. My midline and vertical shift is 17.5 centimeters, and K will be 17.5. And for me to get the equation from our periodic table, this is a equation that I got for my periodic table from my phenomenon. So basically, believe my clock is my periodic table. It's a complete periodic because it repeats itself no matter what, and that's what basically how my project went. That's the reason I got a clock. So I'm gonna be explaining to you why exactly I got a clock. So it's based on same like how I was saying it during the intro. It's towards like the first wheel. That's the reason I got the clock. But besides all that, I believe my phenomenon is a periodic because it repeats itself. There's no kind of errors in it. There's no kind of human errors because a clock just basically repeats itself, and that's about it. Thank you for listening, and I'll see you next time. Thank you very much.